name. Sydney, you can take the whole sheet as the prize. You got the tattoos? No, you can take the whole sheet. Yeah. And did you take the tattoo one too? Yeah. You don't mind bringing that back? I figured they're cool little prizes. All right. So let's go over the do now answer. So what we had was, did I say magnesium sulfate? I'm going to write it this way so I have more space. All right. And what I'm also going to do is I'm going to do them in two different colors so you can see what I mean by swapping the cations around, because you're going to have to do that on the assessment. So we have magnesium sulfate and we had barium nitrate. And I'm running out of space, so I'm just going to write it like that, because I can tell already it's going to be a problem. So that's the word equation. I'll also show you guys the symbolic equation, because really we should be moving to that symbolic level at level 2. So I will have MgSO4 plus Ba bracket NO3 2. Now, just as a nice little refresher, when we are talking about ionic compounds, remember that the first ion that we are writing is always our cation. So this and this are our cations. They are positive. I think positive like a kitty cat. And they always go first. All right. The ones afterwards are anions, which are negative. So these guys back here. They're negative like an onion. And onions make you cry when you cut them. Silly ways to remember it, but it helps. So just keep that in mind, because I do need to use those terminologies, especially a lot for this assessment, because we're going to be talking about how do we identify them. The other thing to remember about ionic compounds is that the charges need to balance to 0. Ionic compounds like these guys here need to have no charge on them. So if I was looking at these as individual ions, magnesium would have a +2 charge, and the sulfate, SO4, has a -2 charge. Now, if I don't know the charges of my ions, that is A-OK, because I have a resource sheet. And on that resource sheet, if I just hunt around for guys, I can see that I've given myself a list of all the ions and their charges. Same thing on the other side. A list of all the ions and their charges. So even though, yes, we are not giving you a table of ions this year, we are giving you ions in a different way. So still look for them. So if I look at the charges of these two guys, I notice that's +2 and -2. That cancels out to 0. So that's why this doesn't have any subscripts below it. Barium nitrate, on the other hand, is Ba2+. The nitrate, if I want to look it up, it's an anion, and I see that it's NO3. Can't really tell on that little sheet, but it is a minus sign. So that only has a -1 charge. So currently, if I add these two ions together, my net charge will be +1. I don't want that. So we're going to need 2 nitrates in order to balance that out, so that this is +2 and that's -2, and thus I get 0. Now, since this is a polyatomic ion, we need to put it in brackets and then put the 2 underneath it. So that's where that's coming from. This is a nice little refresher from last year, hopefully. All right. So now that I know that information, what we're going to do is a little square dance, very American thing. We are going to swap around our cations so that way we can form our products. So in this case, the magnesium and the barium are going to swap around. So that way my new products would be barium with the sulfate. And because I've run out of space, I'm writing this very terribly. You guys will obviously have one nice, neat equation. And then my other combination is magnesium with the nitrate. So those are my two products. I personally like I like symbols because it's faster for me to write it, but I'm writing the word equations just because I know it's the beginning of the year. So all we did was a little swapperoo of these two guys. So if I was to write that down, that'd be barium and sulfate. Now, do you see how I have this as the same number? There's no subscripts there because they're +2 and -2, so I don't need to do that. But with the magnesium, I will need to do that because the nitrate only has a charge of -1. I hope the color coding helps so you can kind of see where everybody's moving. We good so far? So first half of that do now was just trying to figure out our two products, and that's what I wanted you guys to do as part of your homework from yesterday with that precipitation reaction. You realistically only have, I think, 5 to check. I think it's, or maybe 4, because I think I did 1 as an example. So that's the first thing you need to do is figure out what the products are. I've summarized what to do on Google Classroom because I realized I doubled up on the reactions by accident because that was my dummy. Right, so the last thing you then need to do is figure out which one's the precipitate, and that's when these solubility rules come into play. So you don't have to read all of them, you just need to know what you're looking for. So if I'm thinking about what I'm looking for nitrates, I'm looking for sulfates, I'm looking for barium, and I'm looking for magnesium, just to see what their rules are. So I can see already that I have a nitrate being listed as number 3, and it says all nitrates are soluble. And there's no exceptions to that. So what that tells me is that this magnesium nitrate is going to be soluble. So if we want, we can write an AQ next to it because our AQs tell us aqueous. It is dissolved. We good? Okay. So keep looking at my list. We know sulfates was something else that we talked about, and it says all sulfates are soluble. But there's an exception, and that exception includes calcium sulfate, barium sulfate, and lead sulfate. I have barium sulfate. So this would be my solid, and that would be my precipitate. Not all the reactions will have a precipitate. In this case, we do have one. Oops. Let me zoom that out so you can see the big picture. And that was our do now. So that is basically what you guys were looking at for your homework. So this is an example of what you should be answering in your homework. We good? All right, what questions do you have? Nothing? Any requests? We're gonna move on? Okay. Can I move it? All right, cool. Let me pause the recording because I'm not doing notes now. Cool. So like I've been talking about, it is really important to know what is in our water so that way we can take care of it. So like I showed you guys earlier, I had a blue solution that was in my flask here. I drank it and I told you it was Powerade. I don't suggest just straight up drinking stuff that you find in the chemistry lab. The only reason why I did it was because I made it, so I knew. But that that Powerade is there. It looks very, very similar to my copper sulfate, which is also that blue color, right? And if I did a switcheroo and we just did that a couple times, and we didn't know which one was which, then we're really taking the risk now. Now, so first thing I want to ask is what is in that water? Is it dangerous? Is it potentially harmful? So the way we figure that out is we use our resource sheet and our little flow charts. So since we're talking about the copper ion, copper is a +2 ion, so I will be looking at my cation sheet, this one here. And if I look, it says the first step whenever I'm trying to identify a cation is I need to drop 2 drops of the sodium hydroxide, which is what I have here. And I'm just looking to see, do I have a precipitate and what color is that precipitate? If I look at that list. So we have no precipitate, we have white precipitate, we have green, orange, blue, brown. All of those things will help me kind of narrow down and go down a pathway. So if I add it to this one here, we see we have a precipitate, which was my copper sulfate. This one here was my Powerade. Let's confirm that Ms. Garlic did not just poison herself. No precipitate. So that blue solution, even though it looked like copper sulfate, was not copper sulfate. It was just my Powerade. So if I look down on my flow chart and I want to confirm that I had copper sulfate, I would go down and I would look and I see blue precipitate forms, copper, and then there's 2 more steps I can do to confirm that copper. So when you guys are doing this assessment, this is what you will be doing to figure out what do you have as your unknown solution. So I will be giving you unknown solutions and you just follow the steps and you got to identify what we have there. So let's talk a little bit about the assessment while we're here, just so you guys are aware of what the Achieve, Merit, and Excellence look like. Achieve requirements include identifying the unknown ionic compound. You will do that using the flow chart and we will practice that heaps. The other thing you need to do is state all observations, which is why I wanted you guys to do that as a practical, so you get used to thinking about what do I see before, what do I see after. Identifying precipitates, that's tied into that do now that we did today. So figuring out what your 2 ionic compounds could be, and then using the solubility rules to figure out which one it is. And then the last thing on this assessment, so you're gonna have a practical component to it, and you're gonna have a written report. The written report is talking about the impact of those ions. So once you figure out what ions you have, you write a report on talking about the impact of that ion to humans and also to our environment as well. So that's the scope of the assessment. So that's what you need to do for the Achieve level. For the Merit level, you are starting to link. So you're starting to say, I know this blue precipitate is this because blah, 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 blah. And that's what I was having you do as the homework last night. How did you know it was the precipitate? Use those solubility rules to help you justify it. And you can see that's the second point there as well, linking in those solubility rules. The other thing you need to do for the Merit is balancing equations. Again, I will talk about that later. We will refresh how to balance equations. But using those ionic formulas is a good step. And the next thing, again, is linking back to the significance. The difference between the Achieved and the Merit is the depth you go into. So a Merit student would actually explain it a bit more. And then for the Excellence, we're looking at why do precipitates disappear? Again, I'll talk about it when we get to that point in the material. And then the last thing is that comprehensive instead of just explain. So going really into depth and also taking it to that next step and explaining what concentration is in that story. So remember, when we're talking about concentration, it can make the difference between it being beneficial to toxic. My professor at university, when I studied toxicology, he said to us, everything is toxic. All right, just to wrap up then, the last point I was going to make is my toxicology professor would always say, everything is toxic, it is just a matter of dose. And that's what you're thinking about for that excellence, is that dosage. All right, yeah, we're going to get going, that's it. Can you guys make sure to close the windows and put up the chairs and just tidy up? I'll put these notes online. Do you guys want the homework for tonight now, or do you just want to wait till the next lesson? Next lesson? Okay.
Can I choose this one?
No.